Hi everyone, Victor here again, and in today's lesson, we will learn about one of the OpenShift resources called Routes, and we will also learn how to create it. In our previous lesson, we learned how to create service in OpenShift, and we created both internal and external services. And one of the external services we created is the node port. We were able to access our application externally by using the node IP address of where the application was running. Now let's take this scenario. Let's say that my application is a web application, a customer facing application, and an e-commerce one for that matter. For example, Amazon. Would the users use the IP or node information to log into the web app? Apparently, no. Hence, the need to create a route. So with route, users will be able to externally access the application. Hence, route is used to expose applications for external access or to external networks. And to create a route, we need to expose the service because route is associated with service. So for example, if we have pods, then service. To externally access the pods or applications, we need to create a route. The route will expose the service and create a DNS name so that the application can easily be accessible by using the domain. And by default, route generates a DNS name in the form route name dash project name dot default domain. The default domain can be changed, and it is defined in the routing config section of the OpenShift configuration file master.config.yaml, and we will look at how to do that in other lessons. So basically, service is meant to be used internally by the pods and other resources, and route exposes the service externally to clients or users. Another OpenShift or Kubernetes resources that work similarly like route is ingress. And ingress is actually a Kubernetes resource, and route and ingress allow certain types of traffic. Some are HTTP, HTTPS, TLS with SNI, that is server name identification, and TCP UDP sockets. So meaning you can either expose the service in a secured way or in an insecured way. Hence, routes can be secured or insecured. Insecured route doesn't do any form of encryption when there is data transfer or traffic. Of course, no SSL or TLS certificate, so there can't be any form of encryption, while secured route encrypts the traffic from the client to the route and also from the route to the pod. Let's understand this better. In OpenShift, there are three ways which routes can be secured, and they are edge, pass-through, and re-encryption. So what is edge route? Let's use this topology for explanation. With edge route, there is only a level of traffic encryption between the client or user and the route, and that's where it stops. No form of encryption between the route and the application ports. So TLS only happens between the client or user and the route and terminates before the traffic is routed to the pod. And because for edge route, TLS traffic happens and terminates at the router, the TLS certificate for edge route will be configured when creating the route. Otherwise, OpenShift will automatically assign its own certificate, that is, self-signed certificate, to the route. The second type of OpenShift secure route is pass-through. With pass-through, route With pass-through routes, there is a level of traffic encryption between the client and the router, and also from the router to the application ports. TLS happens all through. No form of TLS termination all through from the router to the pod. And because for pass-through routes, TLS traffic does not terminate at the router, the application will be responsible for assigning TLS certificates for the traffic. The certificate can simply be mounted as a secret volume to the application pod. And the third type of OpenShift secure route is re-encryption. With re-encryption, with re-encryption route, there is full encryption from the client to the pod, just like pass-through. But the encryption from the client to the router is different from the traffic encryption from the router to the pod. So you might have different certificates for the re-encrypt route. So having understood routing in OpenShift, let's see the step-by-step guide of how to create this route. So we are going to be creating an insecured route first. And to do that, I'm going to log in as the Cube admin user, so I can just say crc start to get the credentials again. So I can say OC login user name Cube admin and password. I'm just going to copy the password here and paste it here. So you can see that I've been able to log in and I'm using the project app project. And what we're going to do now is to create a pod. And like I explained in the previous lessons, that when you use the OC new app command to create an application, it will create both deployment and service for you. So we're going to be using the OC new app command to create the Nginx application or pod. And to do that, I can just say OC new app. The image is going to be Nginx, and the name I'm going to call this pod is going to be Nginx app. Alright, so we can verify that this has been created, so I can just say OC get pod. So you can see that the pod is running, and of course if I say OC get deployment, we have the deployment, and like I said, the OC new app will create the service for us. So if I say OC get service, we also have the service. So we're going to be creating an insecured route first, which means that we're going to expose this service. And to expose a service, to create a route, we will just use the command OC expose service, then the service name, which is Nginx app. So you can see that it's saying that this service has been exposed. So if I say OC get route, so the cluster is beginning to become unstable. So I'm going to try this command again. So I'm going to do this again. You know, it's just the nature of CRC sometimes to always do this. So I'm going to say OC get route. Now we have the route. So I had to cut off some parts of the video while I was trying to make sure the cluster is back up. So I'm going to run OC get route again. So we have the route, which is, let me try and expand this screen. I'll run OC get route again. So you can see the name of the route, which is also the name of the service, Nginx app. and you can see the service name in the next app, you can see the port, and you can see the URL. And like I said, that it would always take, when I was explaining the default URL for route, I said it would always take the route name, which is this, dash the project name, which is this, dot the default domain name, which is this. And of course, in production environment, like I also explained, you would always want to change the default domain name to what is suitable to your environment accordingly. But for the default, this is what you're going to be having. So if I say call on this route, so you can see that I have my welcome to Nginx outcome, which means that I am able to access the application. And if I also do this on the URL, sorry, I mean on the web, let me bring up the web interface. I'm just going to copy and paste the route here. So you can see that I can access this application, this Nginx application. So this is how you're going to create an insecure route in OpenShift. What I can also do is, so let's delete this route. Also delete route Nginx app. So if I don't want to give the name of this route to be Nginx app, I can also change the name. And to do that, I can just say, let's run this command again, oc expose. So I'm going to say oc expose. Where's our oc expose command? Oc expose service Nginx app, which is the name of the service, and I can say name. I can just give the route any name I wish. So let me just say I want to give the route name tech, for example. I can just say tech, and so if I do oc get route, so you can see that the route name is now tech, and it's going to take, of course, the default, which is tech app project.apps. So this is the default domain that I have in my environment here, which might be different from yours if you're not using CRC. And another thing I can do is, let's delete this again, also delete route. So I can also specify, okay, so we changed the name to tech. All right, so I can also specify the host name. So I can say OC expose service Nginx app. So I can just say dash dash host name. So I can just give any host name. I can say web. Of course, it has to make sure that it's being resolved, that the DNS is working well in your environment. So I can just say web dash app project. I can say that, so app project dot apps dash crc dot test, because this is what is being resolved. This is what is resolvable in my own environment. So I can say yes. So if I say oc get route, so if I say call, let's try this. So could not resolve. So I did not get the name right. It's supposed to be testing. So oc expose, instead of test here is testing. So if I say oc get route and I say call testing here, So we have, yeah, this is what I'm looking for. So we can access the application. So this is how you're going to create an insecure route in OpenShift. So first of all, let's look at how to create the edge route, after which we're going to look at how to create the pass-through route. So to create an edge route, of course, let's see if I have any deployment here. So I don't have any pods running, so I need to create one for this exercise. So I can just say OC new app image. I'm going to deploy Nginx and I can give it a name. So name can be Nginx app, just as we've been using it. So it's going to create a deployment for us, and you can see success here. So if I say OC get pods, it's still creating the pod, and then we have the pod running. And of course, if I say OC get service, it should also create a service for us, but we don't have route. So let's create the edge route. To create the edge route, you can just simply say OC create route. The type of route is edge, and we can give it any name we wish. But I'm going to give this just the same name we give our service. So I'm just going to say Nginx app, and I'm going to specify a service, and the service we are exposing this route to is also Nginx app, right? And if you wish, you can specify a host name, but I'm not going to do that. If you want to do that, you can do that. So I'm going to create this route, and now you can see that the route has been created. So if I say OC get route, you can see that we have the route being created as Nginx app, and you can see the termination type, which is edge. And if I try to, so let's copy this URL and let's try to log into the application via the web. If I copy and paste this here, so you can see that it's saying application not available. So that's because it's still trying to use the HTTP. So I have to put the HTTPS protocol, and you can see that we can log in. And if you look at here, you can see some sort of protection here, right? Protection for Nginx app, blah, blah, blah. And in the previous one we created, you would see something like connection insecure. In the insecure route we created, you would see stuff like that here saying connection insecure. Just going to disable this for now. So I want to show you something. So it's saying you have site information, blah, 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 connection not secure. And that's because we're using a self-signed certificate, which was done by OpenShift. Like I explained that OpenShift will automatically generate a self-signed certificate, and the browser does not recognize the CA, that's the certificate authority from OpenShift. If it were to be the common ones like Komodo and all of that, you would have seen that it will tell us that the site is secured. However, if I click here, I want to look for the SSL information or the TLS information. So you can see it's verified by this CN ingress operator here, and it expires in 2024. I can say view certificate. You can see the certificate here that is being provided by OpenShift, and you can see ingress operator here too as well. So let me try and bring this up a bit so you can see very well here. So you can see the issuer name, common name, ingress operator at this. And that's because, like I said, this certificate was automatically generated by OpenShift for us. So having understood this, let me also do this test on the black screen on the CLI, so you can see that we can't log in into this application because of these TLS certificates that we have. So if I do call, of course, HTTPS now, and I try to log in, you can see that the SSL certificate problem, self-signed certificate and certificate chain, call failed to verify the legitimacy of the server and therefore could not establish a secure connection to it. So like I said, because we have a self-signed certificate that is not recognized, right? So having understood this, let's also create the pass-through route. And like I explained to you that the pass-through route is the type of connection that is encrypted from end to end. So let's create one. So I'm going to delete this route. Let's get route. Let's say delete route engine X app. All right, so let's see get service. Get service. So I'm also going to delete this service engine X app. OC delete deployment. So let's delete this deployment too as well. All right, so I think I have a clean system now. So what we're going to do now is to create pass through the pass through route. And so let's do it this way. First of all, we need a TLS certificate, and you can get this certificate. You can buy it. Of course, like I said, you can buy it from trusted certificate issuers like Commodore and the likes. And because I don't have any certificate here, so I am going to, of course, generate one by myself. So we can also use the OpenSSL tool to generate a self-signed certificate by ourselves. So if you're buying a certificate, what you need is the TLS or the SSL certificate and the primary key. Those are the two things you need. And because we don't have that, I'm not going to buy that. I'm going to generate that. So and like I said, I'll use the OpenSSL to do that. So let's just generate one by ourselves. If you're familiar with the OpenSSL tool, you would know how to generate a TLS or SSL certificate. So what we're going to do is I'm just going to go to certificates directory. You can create one. And if I do ls, I have a configuration file here. So let's see this configuration file so you can see what I have here. So if I do vi config, app config, so you can see here I have requirement, I have default bit, I have prompt, I have all these parameters, and I have this distinguished name. If you come here, you can see I have country NG, which is Nigeria, state Lagos, L location Ireland, organization technique, OUIT. So these are the information I need to be able to generate my SSL certificate. So this is just like the CA, the information you need for your CA. So now that I have this information here, I can save this file. I'm going to be posting the link to this particular lesson in the description box below, so you can always navigate through and copy and paste if you need to modify it to your own environment accordingly. So now that I have this configuration file, we can use the OpenSSL tool to generate our TLS certificate. And to do that, the first thing we need to do is to generate our private key. And the command I'm going to use to generate the private keys. So I'll just copy it straight away from the website. I'm going to paste it here. So I'm saying that I want to generate an output of this file. So the output, this dash out is an output, and I'm going to save the file name as app.key, and this is the bit size, right? So this is going to generate an RSA private key for us. So I can say enter. So if I do ls, you can see that I have the app.key file. And the next thing I'm going to do is to generate a CSR certificate, which is certificate signing request. And the command I'm going to use to do that, I'm also going to copy it from the website and paste it here. The parameters are self-explanatory. So this is out, meaning that this is the file name. It's going to save the CSR as this name, and it's going to use this config file, which is app.config. So this is the config file that it's going to use. So I can just say enter, right? And the third step I'm going to do is to generate a root certificate. I'm also going to copy the command and paste it here. So if I copy this command and paste it here, you can see this too is also self-explanatory. And if I say enter, if I do ls, you can see the CSR and you can see the root certificate. You can see that the output is ap.crt, which is what we have here. And lastly, we're going to generate the final certificate, which is the main certificate. So to do that, I'm still going to copy the command, and these parameters are self-explanatory, so you can just, you would, of course, you would know what these things are doing. And if you're familiar with OpenSSL, it's an added advantage for you. So this would generate the main certificate, which is the final certificate. You can give this any name you wish. I'm just giving this name main.crt. And this certificate is going to last for 365 days. You can choose whichever days you want this to last. And if I do ls, you can see that I have my main certificate and I have the primary key here. That's what you're going to be given to even when you buy a TLS or SSL certificate from a third party. Okay, now that we've been able to do this, the next thing we need to do is to create a secret using these two parameters, using the private key and the certificate itself. And don't forget, in our previous lesson, in one of our previous lessons, we've already talked about creating secrets. So this should not be a new thing. And I'm not going to use a YAML manifest. I'm just going to use addoc to create secrets. I can say also secret is going to be a TLS type of secret. So I say also create secret TLS, and I'm going to give the secret name. I can say engine X secret, and the sat is going to be main.crt, and the key is going to be app.key. So it's saying that this certificate already exists, right? So I'm going to just delete it because I don't know what I used to create the certificate when I did it. So I'm just going to say also delete secret. Secret exists. So nginx secret, nginx secret, nginx. The server doesn't have a resource type secret. Oops. So I'm going to create this secret again. Alright, so if I say also get secret, so you can see that we have the secret being created. Now that we've been able to create this secret, we can now mount this secret inside of the deployment that we want to create. And this is not a new thing as well. We've done this too in one of the previous lessons when we were mounting volumes. We mounted config map and secret. So this is never a new thing to you if you've been following my course so far. So let's mount this secret as a volume to to the deployment we want to create. So I'm just going to go back to my home directory. I'm going to be creating this deployment, which is a deploy.yaml. So if you look at this file, deploy.yaml, so you would see that from here, it's just a YAML manifest to create deployment, API version, deployment, Nginx, and if you come to volume mount, of course, the name of the volume, so you can look at it from volumes here, right? So the name of the volume is Nginx secret dash file, while it's a secret type of volume, and the secret name is Nginx secret. And on the container part, we're going to be mounting this secret, right, to this path, and it's going to be a read only. So for the, if you scroll down again, so I have two manifest files for both deployment and service here. And if you look at the service too, you can see that this is service and the metadata is Nginx app. Of course, the selector is app Nginx. So I can deploy this, I can create and deploy this deployment. So I can just say also create, what did I just say? I can create and deploy. So I can deploy this or create this. So I'm going to say also create file deploy.yaml. So you can see that I have both deployment and service being created. If I say also get ports, so it's already running. And if I say also get, of course, deployment, so I have the deployment running. And if I say also get service, so I have the service to here being created, and I can even verify that the volume is already mounted inside of the container. And to do that, I can just say oc describe pod. So our pod name is this, and I can just grep. I can grep for mount. Okay, so I can use this so I can see the header. So all right, so you can see that we have this being mounted here, and it's a read only type. So this is fine. Now that we have our service, like I said, like I explained, that a pass-through route, of course, you can mount the certificate from the application side, which we've done, and the certificate that we've mounted from the application side will be responsible to do the encryption, right? So now that we've been able to do all of these processes, what we need to do next is to create the pass-through route. And to do that, of course, I can say also create route pass-through pass. So the type of route is pass-through, THROUGH. Pass-through, I'm going to give it a name. You can give it any name, so I can say Nginx app, and I'm going to point it to a service, and the service too is Nginx app. And if I wish, I can specify a port, right? So I can say port. I think I have that port on my service. I think I have that port on my. It doesn't matter anyway. I'll just say port 8443. Alright, so the route has been created. So if I say also get route, you can see that we have the route here being created, and it's a pass-through route. So we can copy this and check from the web UI. So we can just paste this here, and of course it's HTTPS. So we have this here. You can see that we can log into Nginx. You might also have the site is not secured output on your browser too, and that's because we're using a self-signed certificate. If you get a certificate from um a known issuer, certificate authority issuer, it won't tell you that. And if you don't want to always see that too, you can add that certificate to your browser so that your browser will stop telling you that it's insecure. And if you wish, you can also create a debug pod to test with the call command, right? So this is how you would create routes in OpenShift. And I want to say thank you for watching. And please don't forget to subscribe to this channel, like, share, and comment. When you do this, you encourage us to do more. I'll see you in the next lesson, and bye for now.